Good evening, my dear students. And yesterday we have done one problem. Once again, welcome to science class. One more problem is left. That is example 12.11. Welcome you once again. .11 that we are going to discuss today. So what's that? 100 joule of heat is produced each second in a 4 ohm resistance. Find the potential difference across the resistor. Okay, 100 joule of heat is produced each second in a 4 ohm resistance. Find the potential difference across the resistor. Then solution. For that, I am writing the solution. How we can find the heat? Heat is equal to 100 joule. What is given? We have to write first. So, heat is given 100 joules. Then resistance is given, no? Resistance which is 4 ohm and time is equal to 1 second. And we have to find what? Potential difference across the resistor. V we have to find. Okay, V is equal to what? Okay, so to find V, we have to find current I. Okay, from equation 12.21 in your textbook or in the derivation which we have done, we will get H is equal to I square RT. Then we will get I is equal to root H by RT. So on substituting the values, we will get what is the value of H? 100 joules by R 4 ohm and time 1 second into 1 second. We will get it like this. What value we will get? That is equal to 5 ampere. We will get the value of current I is equal to 5 ampere. We will get the value of current as 5 ampere. Then how we are finding potential difference? That we are knowing. Yes or no? Potential difference V is equal to IR. So in this equation we are providing what? I is what? 5A and R is what? Into 4 ohm. 5 into 4, 20. 20 watts is the answer. So no. $20 watts is the answer. Here we substituted the value and we get the answer as 20 volt. And what is left next? Here we are going across the questions. Okay, 3 questions are there, and let us go through the questions. First question: why does the cord of electric heater not glow while the heating element does? Okay, the question is, why does the cord of the electric heater not glow while the heating circuit does? Or heating element does. So let us give the answer. That is first question answer. The answer is the heating. We know that the heating element of the heater are made of what? Metals. It is made of alloys. Okay. They are made of alloys. Which is, what is the specialty of alloys? It is having high resistance. Which is very high resistance. It is having very high resistance. So, when current flows through the heating element, when the current flows through the heating element, it becomes too hot, glows red. Did you see that? Glows red. But what about the code? What about the code? But the code CORD, but the resistance of cord, which is made of copper or aluminium. What happens? The resistance of copper or aluminium is very low. It's very low, so it does not glow. It does not glow. Got the answer, no? Why does the cord of the electric heater not glow while the heating element of glows? Okay. The answer is the heating element of the heater are made of alloys, which has very high resistance. So when current flows through the heating elements, it becomes too hot and glows red. But the resistance of the cord, which is made of copper or aluminium, is very low, so it does not glow. So let us move to our second question. What is the second question? Compute the heat generated while transferring 96,000 coulomb of charge in 1 hour through a potential difference of 50 volts. Okay, we are going through that solution. What is the question? Compute the heat generated while transferring 96,000 coulomb of charge in 1 hour through a potential difference of 50 volts. And we are going to do the solution. While doing a solution, we have to write the given things. What are given? Charge Q equal to what? 96,000. 96,000, no? Yes. Time T is equal to 1 hour. Then potential difference V equal to 50 volt. What we have to find? We have to find the heat generated. We have to find the heat generated. So, charge is given time. Time we have to change it to second. That is and potential difference V is there. So, let us calculate current. Okay. Let us calculate current. Current I is equal to Q by T. Q by T, which is equal to, what is Q here? 96,000 by time 3,600. We will get I is equal to 80 by 3 ampere. The unit of current is ampere. Then what we have to find out? We have to find out the heat. We have to find out the heat generated. Is or no? So let us find out. Let us find out the heat generated. Let us find out the heat generated by using the formula, that is H is equal to V into I into T. What is V here? 50 volt, and I is equal to 80 by 3. Time is equal to 3,600 second. So we will get heat is equal to, on calculating we will get 4.8 into 10 raised to 6 joules as answer. Okay, we will get 4.8 into 10 raised to 6. Therefore, the heat generated is 4.8 into 10 raised to 6 joules. Okay, is it clear? What is our next question? An electric iron of resistance 20 ohm takes a current of 5 ampere. Calculate the heat developed in 30 seconds. An electric iron of resistance 20 ohm takes a current of 5 ampere. Calculate the heat developed in 30 seconds. And we are going through the solution. What is given? Current I is equal to 5 ampere. Time T is equal to 30 seconds. 5 ampere. Resistance R is equal to 20 ohm. So, the amount of heat H produced is given by the which law is there for heat? Joule's law. Joule's law of heating. So H is equal to VIT. So what we have to find? I is here, T is here, but V is not there. V is equal to I into R. So no, V is equal to I into R. That is, what is I? 5 ampere into R, 20. That we will get 100 volt. We will get the answer as 100 volt. Volt is equal to 100. Potential difference V is equal to 100. So, we are having the equation for heat H is equal to VIT. H is equal to VIT. What is V? 100. I 5 ampere and time 30 seconds. What we will get? We will get 1.5 into 1045. Therefore, the amount of heat produced, heat developed in iron is what? 1.5 into 1045. Sorry, 1.5 into 104 joule. Okay, 1.5 into 104 joule is the answer. Okay, so this is all for the day. Here in this step you check 1.5 into 1.4 joule. Joule is the unit of heat. Okay, here also 1.045 1.4 joule. Okay, so please go through that. Here this is 1.4 joule and here also 1.4 joule, not 1.45. Okay, thank you so much. This is all for the day, and tomorrow we will come with another section. Thank you so much.